Welcome back to our ongoing discussion of SQL. This is video number 4, corresponding to chapter number 4 in the free SQL book. This video talks about the keywords and or not, which are used in where clauses. What these keywords do is take a simple condition, like state is equal to AZ, and another simple condition, like phi is equal to 0.00, and forms a compound condition by using the keyword and to connect those two simple conditions. Instead of and, we could have done or. Alternatively, we could take the simple condition and negate it by putting the keyword not. Now, when we get into section A, the first section in this presentation, where we take a look at and or not, for the most part, this will conform to your intuition, even the people who are rookies. All right? The second section gets a little trickier because we start to mix different logical connections where we have three simple connections, something like condition 1 and condition 2 or condition 3. Things get a little stickier there, and here's the rookies need to pay attention. The third section is kind of an optional section with one exception. I think the application developers should pay close attention to this particular section. All right, let's jump right in and get going. Our first sample query specifies the keyword and. The query objective is to display all information about any nature preserve that's located in Arizona and has no admission fee, which means the fee is 0. So we have two simple conditions. State is equal to Arizona, fee is equal to 0.00, and we and connect those. We look at the state column, we look at the fee column, and we see both of those conditions are true. But the other 13 rows in this preserve table, one or the other of both of those conditions fails. Now, I'd like to get a little formal for a moment for something which is pretty simple, actually. The truth table for the keyword and. If we let C1 and C2 represent any arbitrary conditions, there are 4 possibilities. The first one's true, the second one's false. Oops, excuse me. Or the first one's true. Let me start again. The first condition is true and the second condition is true. In that case, when we say C1 and C2, we say that compound condition is true. The other 3 possibilities, true, false, false, true, or false, false, all lead to false results. Basically, what we're looking at in this truth table is the formal definition of the keyword and. Both conditions must be true in order for the compound condition to be true. We take a look at the second sample query. We see 2 simple conditions. Acres is greater than 90 and acres is less than 1,200. And then we join it with and. Note that both of the simple conditions reference the same column, acres. Now let's look at the query objective. Display P&O, P-name, and acres values for any nature preserve with an acres value that is strictly between 90 and 1,200. Therefore, what we see is a greater than symbol for acres greater than 90. We don't see greater than or equal to. And in particular, when you look at the values in the result table for the acres columns, you'll see values strictly between 90 and 1,200. If you wanted it to be between and including, then the symbols would be greater than or equal to or less than or equal to. The next sample query just specifies multiple and conditions. This and this and this and that. And when we code something with multiple conditions, in this case 4 conditions, 4 simple conditions, connected with a bunch of ands, it's pretty simple. All the conditions must match. So here it says, give me the number, name, fee, and acres from the preserve table, where the nature preserves are located in Arizona. They have a non-zero lab fee. Fee is not equal to 0. And the emission, the acres, is greater than or equal to 660 and less than or equal to 1200. Now, there's 2 rows that match this condition. These are the 2 Arizona rows, okay, where the fee and the acres match. So, putting together any number of simple conditions, in this case 4 conditions, where they're all connected by the same symbol, the same connector, the keyword and, is logically pretty simple. It's got to match all conditions. Now we look at the OR connector. It means one or the other or both conditions are true. Let's look at the query objective. Display the P&O, P-name, and state values of all nature preserves that are located in Montana or Arizona. So here we have state is equal to Arizona, state is equal to Montana. We have an OR connector. So it matches one or the other or both. Here's an Arizona preserve. There's a Montana preserve. Okay. Here's the formal definition of OR, and we use a truth table for that purpose. OR means if one or the other condition is true, or both conditions are true, is true. So true and true produces true. Excuse me. True and false, I should not have said that. True or false is true. False or true is false. The only time you get a false result is when both conditions are false. All right. OR means inclusive OR. By the way, there's this thing called exclusive OR. We'll say a word or two about later on. Let's talk about the inclusive OR. Display the name, acres, and state values of any preserve that is located in Arizona or has more than 1,000 acres. Here's the first condition. Here's the second condition. They're connected by the keyword OR. Now, if the state is equal to Arizona, we don't have to care about the acres. If the acres is greater than 1,000, we don't have to care about the state. But what if, as is highlighted here, the Muleshoe Ranch matches both conditions? It is selected, and there's one more row that matches both conditions. It's selected. This means it's the inclusive OR. It's not an exclusive OR. Let me tell you what an exclusive OR is. Say you said to your young child, you could have a piece of pie or a piece of cake. Implicitly, you're saying you can have a piece of pie or a piece of cake, but you can't have both. And that means one or the other, but not both. That's an example of the exclusive OR. You could have multiple conditions joined together with this or this or this or that, and they've only got to match one of the conditions. This sample query says, display the P&O, P-name values for any nature preserve that has a P&O value equal to any value in this list of values. 3, 4, 7, 12, 40. If we look to this, we're asking, is the P&O 3, or is the P&O 4, or is the P&O 7, etc. We look at the result. We see 4 rows that were selected. It was only the case that there is no preserve with a P&O value of 4. Pretty simple, pretty straightforward. By the way, in the following video, we'll see there's a way to make this more compact with an abbreviation using a keyword in. Now we take a look at the keyword not. Sometimes it's easier to say what we don't want. So here's an example where we want the name and state of all nature preserves that are not located in Massachusetts. Maybe I live in Massachusetts. I've visited all the preserves. I know I've visited all the preserves. Give me a list of all the others. So we say state is not equal to MA. Now, because this table's only got preserves from Massachusetts, Arizona, and Montana, when we look at the result, we get just the Arizona rows and the Montana rows. The truth value for this keyword not is pretty straightforward. If C1 is false, if C1 is true, then not C1 is false. And if it's false, not false is true. Now, this completes the basic core logic of and, or, and not. And I went through this rather briefly. You could stop and take a look at it closely if you're a little confused at any point. But when we move on to the next section, things get, a little trickier. Let me describe the nature of the problem. Instead of having this and this and this and that, or alternatively this or this or this or that, we're going to have a condition which says or and, or we can turn it around and say or and again. What's the difference? Well, here's the difference. The system has to decide to go ahead and do the and logic first, get a result, a true-false result, and then use the or condition to take that result and can compare it to the first conditions, acres greater than 1,000. Alternatively, the system might decide to do the or condition first and get a result and then do the and condition. So what does it do first? It does what you tell it to do. When you put parentheses around the two simple conditions that are joined with and, you're telling the system to do the and logic first. Alternatively, when you put parentheses around the or, you're telling the system to do the or logic first. This is kind of like doing an addition and multiplication. Okay? If you're going to have multiply and add inside a mathematical equation, you want to use parentheses to identify which one you're going to do first. Now, I emphasize that we're going to see sample query 4.8. And the way we articulate that query, it implies that you want to do the and first. Then we're going to see sample query 4.9. It's going to have the same conditions, but the way we articulate the query objective, it implies we want to do the or condition first. Now, these where clauses are not equivalent. They return different results. And that's where the tricky part comes in, articulating a query objective and deciding which logical operation, the and or the or, you want to do first. Hey, what if you do not specify parentheses? Then shame on you, don't do it. Okay, I'm not going to tell you now. The system will do one or the other, but forget about that. Even if you know what the system's going to do first, specify the parentheses. Now let's look at a concrete example. Sample query 4.8. This sample query requires some analysis. And in fact, the hardest part for me of putting together this page was trying to precisely, concisely, and unambiguously articulate the query objective. Let's take a look at it. Display the p-name, state, fee, and acres values of any nature preserve with more than 1,000 acres, that's condition 1, comma, or any other preserve with any other Arizona preserve with a $3 admission fee. Now, the logic shows an or condition here. That's this or. And now when I say Arizona preserve with a $3 admission fee, what I'm really saying is the state Arizona and the fee is $3. And these two terms are logically coupled together, all right? Logically, I want to do the and before the or. The condition is if it's 1,000 acres, I want it, or if the state is equal to Arizona with a $3 fee, I want it. Now, to work my way through a concrete example, I just picked one row, the mule shoe ranch row. And what I'm demonstrating here for one row could be demonstrated for all 6 rows in the result which matched this condition. So I'm considering the mule shoe ranch row, and I'm going to dissect that with great pain. I'm asking the rookies to pay close attention. So here's my where clause with 3 conditions. Acres greater than 1,000, state equal Arizona, fee equal to $3. And I'm going to evaluate each individual condition. For this particular row, is the acres greater than 1,000? Yes, it is. It's 49,000. That's true. For the state of equal to Arizona, is that true? Yes, it is for that row anyways, and that's true. And in that row, is the fee equal to $3? No, it's $0. That becomes false. So what I've done for this particular row is reduce it to true or true and false. Now I think in terms of truth tables. I don't have to think in terms of acres, states, and fees. And because the parentheses are around the and, I do that first. Now, the and condition is only true when both conditions are true. Otherwise, it's false. This is a true and a false. That evaluates the false. Now I can take this true, bring it down. Take this or, bring it down. And now my logical condition is simplified to a true or false. Now, according to the truth tables, an or condition is true if one or the other or both conditions is true. And one of these is true, so the final result is true. And that is how the mule shoe ranch row is selected to appear in the result. Now, what I would invite you to do is to take any other row, pine, butte, swamp, and work through the same logic I've demonstrated here, and you will get it true. Now, pick any row not shown in this result. That other row was rejected because if you do the same type of analysis, its final result will be false. And that happens on the next page. I bring to your attention again, briefly, is that the next sample query is going to have the same acres greater than 1,000, the same state equal to Arizona, the same fee equal to $3, but the query objective invites us to put the parentheses around the or. I'll be brief on that. Let me just go through the process. Display the name, state, fee, and acres from any nature preserve where it's more than 1,000 or is located in Arizona and has a... Okay, let me state this. I'm going to start again. Display the name, state, fee, and acres of any nature preserve with more than $1,000 or is located in Arizona, comma. So that's going to be this first part here. And furthermore, has a $3 admission fee. And for the sake of emphasis, I'm saying has a $3 admission fee regardless of its location and acreage. This was difficult writing the query objective also. It was easier for me to write out the where clause. Anyways, I'm going to have you make an assumption now. I did a decent job stating the query objective. And this where clause does indeed conform to the query objective. Now we proceed. What rows are selected by this query objective? There's just 3 rows where on the preceding page there were 6 rows in the result. The difference occurs because we decide to do, for the sake of the query objective, the OR logic first. We're going to pick the same mule, shoe, ranch row we analyzed in the first page and observe that it's not in this result. That means it evaluated to false. So here we go through the details again, but we're going to get a different result. Acres greater than 1,000, or state is equal to Arizona, or fee is greater than $3. Is acres greater than 1,000? For the mule, shoe, ranch, yes, it's 49,000. That's true. Is state equal to Arizona? Yes, that's true. And what about the fee? Is it equal to $3? That's false. So now we're thinking in terms of logic, true or true and false. Okay. The parens are around the first 2 conditions, true, because that's the logic that we've specified in our where clause. And now we're thinking in terms of truth tables. The parens are around the true or true. Well, that evaluates to true because or reduces to true if it's one or the other or both, and in this case, both of the conditions are true. And we just take the false and the and bring it down, and now we have a new comparison, true and false. Well, and only evaluates to true when both conditions are true. Here, one of them is false, so the final result is false. And therefore, the mule, shoe, ranch did not appear in the result. One more time, I invite you to take any row in the result table, go through a similar analysis, and you will see that it evaluates to true. But if you take any row not in the result table, similar to mule, shoe, ranch, do the similar analysis, and the result will be false, which is why it's not in the result. I'd probably encourage rookies, if they're still hanging in here with me, I hope they are, to pause this video and work their way through some of these before proceeding on to the next sample query. Okay, we'll do that. And sometimes it is easier to say what you don't want. Display every row except this. Display the P&O state and fee values of every nature preserve except. That's going to be a not. It's going to be except something. Except those preserves that are located in Arizona and have a $3 admission fee. So here we're saying not in front of a compound condition. All right. So what we do is find the rows that are Arizona with a $3 fee and exclude all the others. All right, so this is pretty straightforward. What if we don't have parentheses? Shame on you if you do that. Don't do it. However, if somebody else got sloppy and didn't use parentheses, and you were looking at their code and trying to figure out their logic, you have to mimic the system and do what the system does. Here we're telling you nots are evaluated first, then the ands are evaluated second, and then the ors are evaluated third. Let's take a look at an example where acres is greater than 1,000, or state is equal to Arizona, and fee is equal to $3. Now, there's no nots in this condition. There's only ands and ors. What do we have to do? There's no nots, so and is done next. And the state equals to Arizona, and fee is equal to $3. Okay, that is done first. Now, let's take a look at this. So that's why we have parentheses here. Let's look at a second example. We're not $3 or acres is greater than 1,000 and state is equal to Arizona. Well, what we have to do is do the not condition first. And we say we want those rows where the fee is not $3. Now we have what is left over. We have an or and an and. There's an or condition. There's an and condition. The and condition is done next. So after we evaluate the not condition, we evaluate the and condition. Then we take the two results and or connect them. Here is an ugly where clause. I'm not going to explain it, except I take a condition, specify an or, then specify an and, which connects a symbol with a not, and there's absolutely no parens. The way it works out is when I take and put a not around the not condition first, then have an or with the parens around the and the book will take you through the details of this logic. Don't do this. It's ugly. It's a bad example. Okay, that concludes section B. And again, for the rookies, where section A is easy, I encourage you to take a look at the discussion of the examples in section B. Section C says, can we take two where clauses that produce the same result, and by that I mean they produce the same result, get the same result rows, but the where clauses are different? The answer is yes. There can be multiple right answers. Let's put it that way. Here's a trivial example. All right. Say I want information, rows from the preserve table, about all the preserves except Massachusetts. I can say, we're not the case that state equals Massachusetts. But you might say, hey, why don't I just say state and use the not equal symbol? Good observation. Therefore, both of these where clauses will produce the same result. They are logically correct, both of them. Which one might be more efficient? I don't care about. Which one might be friendlier? I don't care about at this level anyways. Now, this is a trivial example. Sample query 4.8 that we saw a moment ago. Let me go back to it. Acres greater than 1,000 or state is equal to Arizona, and the fee is equal to $3, I mean. Now I can take this code and rewrite it as the following. I can make it bigger. And I'll take a look at that in a moment. But I want to say, if there's 10 people looking at this presentation right now, I bet no more than 2 of them say, oh, that's obvious. Because it's not obvious. All right? Unless you've been looking at logical exercises recently. Now, let me kind of give a hint here as to what's going on, and I'm going to help you do this. All right? You see this condition, the or is greater than 1,000, acres is greater than 1,000, acres greater than 1,000 here, and acres is greater than 1,000 there. It's put in front of both of these other conditions. Acres greater than 1,000 in front of the state condition, and acres is greater than 1,000 and greater than fee condition. I'm going to explain this in a little bit, but I might encourage you to pause the video and take a second look, all right? Sample query 4.9. There we coded an or condition within parentheses and then say, and fee is equal to $3. Now let me make a first jump here. I'm going to take this fee is equal to $3 and move it up front and connect it with the and right here. So that's practically obvious. All right, just resequence them. But then the next one is not immediately obvious. Because we got this fee equal $3 in front, we're going to specify it here and here again. I'm being very casual and very brief. I'm putting it in front of the 2 conditions in parentheses. And here again, I have not explained this. I invite you to pause the video and see if you can figure out what's going on here. All right? That's why I say this is not trivial. In sample query 410, we said we do not want information about any preserve in Arizona that has a $3 fee. Now this is equivalent to this thing. And that's not immediately obvious for most people. Once you get it here, though, you could say, if you wanted to, I've got not in front of this thing and not in front of that thing. And I really like the not equal sign. So instead of saying not state is equal to Arizona, I use the not equal symbol here. Instead of saying not fee is equal to $3, I use the not equal fee here. But when we went from one condition to another condition, it was not immediately obvious. So here's the interesting questions. One is, and I didn't answer this yet, how you really know that 2 where clauses are equivalent. I gave you 3 examples, invited you to pause the video and take a look at this. All right? I'm going to give you an answer in a moment, and we're going to fall back on the laws of logic. I call it logical gymnastics. But that seems like an academic exercise. So does this equivalent where stuff really matter? Well, maybe, because someday you might have to read another user's where clause. And if there's multiple ways to produce a correct where clause, then person A might have a different logical mindset than person B. And person B might have to analyze a where clause coded by person A. Why? Maybe they're changing it or enhancing it, or maybe person A made a logical mistake, which was discovered 2 years later. Now, which one's friendlier? If you've got two where clauses, which one's friendlier? I'm not going to say it's intuition, it's cognitive psychology. But here's the interesting question. Is either of the two where clauses more efficient? Now that gets us into a discussion of query optimization. If you have been reading the appendices on efficiency in query optimization, then you will be aware of the fact that the optimizer, whatever the optimizer is, this is under the hood stuff, might take one where clause and rewrite it so it's equivalent but in a different form and generate, it's called query rewrite. And that's an important concept pertaining to query optimization. Okay, let's talk about laws of logic and logical gymnastics. Okay, so here we are. Most users rarely have to play this game. I'm giving the rookies a pass on this. Okay, actually in a typical course, when I taught live SQL courses, I didn't have the time to go into this level of detail. I would describe the problem, raise the level of anxiety, and say if you bump into a similar problem, go back and take a second look at the notes in the book. So let's start off with a where clause that has a logical expression, and we'll just assume it's correct. I want to convert it to a second logical expression. It's going to be a different expression, but it's going to have the same logic, retrieve the same rows. Now I got to ask, how do I know if this second expression that I've just produced is indeed logically equivalent? Here's the answer. You follow the laws of logic. Now that sounds terrible, but once you get used to it, it's kind of easy because it's mechanical. It's cookbook, and I'm going to show you some examples now. So here's the law of logic. It's called the distributive law of OR over AND. Now, you may have remembered in junior high school that you can distribute multiplication over addition. 3 times 5 plus 6. And you could 3 times 5 plus 3 times 6 and add them. Okay, this law comes into play in sample query 4.8. But let's take a look at this law. If I've got C1, condition 1, or some compound condition, I can take the C1 with the OR, and bundle them together. Then I can take the C1 OR and bundle it with C3. And I take this and I put it between the two here. We have distributed the OR over the AND the same way we distributed multiplication over addition in freshman year algebra. So here's the mechanics. Acres greater than 1,000 or this compound condition. Take the acres greater than 1,000, take its OR, and put it in front of the first condition. Take the same acres 1,000, greater than 1,000, with its OR, and put it in front of the third condition. And now you've got two conditions. Then we take this and drop it right here. Now, somebody might say, this second condition, this second equivalent condition is longer, and therefore it's less friendly. Somebody else might say, I think it's logically cleaner. It expresses more what I want to say. I'm not going to go into that discussion now. You can also distribute the and over the or. Now, in high school algebra, you could not distribute the plus sign over the multiplication symbol, all right? But here's again, so here's C1 and a compound condition involving or. So we take C1 and C2, then take C1 and C3, take the or, and connect those two compound conditions. In sample query 4.9, in order to set up the application of the law in a simple manner, I initially took this fee of $3 and swapped it and put it up front, and I swapped the and conditions. If you're a math major, you know I'm talking about the commutative law of and. Forget about that. Then I have a condition here, excuse me, if you will, this condition fits the general form expressed on the top. Let's take a look at it. Phi is equal to 3 and something. Phi is equal to 3 and the first condition, acres greater than 1,000. Phi is equal to 3 and the second condition. Okay, take the or and drop it between those two conditions. Again, we have generated a longer second condition, second compound condition. And if you like it or you dislike it, that's your judgment call. Here's an example of De Morgan's laws. And we ran into this in sample query 4.10. Let's take a look at the law itself. We've got a not in front of C1 and C2, all right? Now watch what we're going to do. We're going to put the not in front of C1, then we're going to put the not in front of C2. So the not goes in front of C1, and the not goes in front of C2. But here's the gotcha, the one that surprises people and almost makes this counterintuitive. See this and? It becomes an or. Now, if I take the not and put it in front of an or, after I put not in front of the first condition, second condition, this or becomes an and. So there's really two laws that fall into the category of De Morgan's laws. So let's see what we're going to do here. In sample query 4.10, we had not in front of a compound condition where the first condition was and connected to the second condition. This and is going to become an or. Then we put the not in front of the state, equal Arizona, and the not in front of the fee equals $3. Now, you might look at that and say, I prefer not equal symbols. Okay? So what I'm going to do is say, not state equals Arizona is just state is not equal to Arizona. And not fee is equal to $3, and fee is not equal to $3. And I rewrote it again. Now I might look at this and say, hey, I don't need these parentheses. So I'm going to throw those parentheses away and write it in what most people would think might be its simplest form. So what we have done here is we took the compound condition and a where clause and rewrote it 3 different ways, and somebody might like the last way and say, hey, that's the simplest of all of them. Again, that's cognitive psychology, and and that's a judgment call. What I'm bringing to your attention here is that I have presented in the last few minutes 3 laws of logic: the distributed law, the second distributed law, and then 2 of De Morgan's laws. And I want to verify the equivalency because I said we can do it by the laws of logic, but how do you really know those laws of logic are true? Okay, this is mental gymnastics. And what I'm doing here is proving one of De Morgan's laws. I want to show you that not a compound condition connected with and is this and becomes an or after I put a not in front of both conditions. Well, how do I do that? Okay, what I'm going to do is to take this condition, this not condition here, and I'm going to generate a truth table for it. And that's pretty simple. Let's take a look at this. If I take just the C1 and C2 part and put it right here, we know that C1 and C2 is only true when both are true. So it's true, false, false, false. And when I put a not in front of that, it's false, true, true, true. Now, if I get the same false, true, 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 when I do the second condition, then they must be equivalent. So let's take a look at the second one. Here's C1 and C2. What I'm going to do is figure out not C1. You know what not C1 is? Take anything which is a true and turn it into a false. Take anything a false and turn it into a true. Just swap them. Same thing with not C2. If C2 is true, false, true, false, this becomes false, true, false, true. Now I want to take these 2 conditions, and join them with or. Well, what happens? In order to be true, one or the other or both must be true. Well, the first one's not true. Oops. The first one's not true. The second one's not true. So when I or them, it's false. The other 3 conditions, one or the other is true. Now, with great emphasis, here's a condition. Here's a condition. They both have the same truth table values that we work through. Ergo, they are equivalent. So what we've done is validated the laws of logic. Just one example here. There are others in the book. So that is what we have done. Okay. So finally, what do you want to do in terms of learning the laws of logic? Well, as I said, you might review this video and determine are 2 where clauses equivalent. Well, you got to understand the basics as described in Section A and Section B. Get that down first before you jump into Section C. Well, you do your best to figure it out, but you know what? You might have had a bad night last night. You don't want to figure anything out. So here's what you can do. You can figure out, well, here's where condition 1. Here's where condition true. Why don't I put them both in 2 select statements, run them, and see if I get the same result? Well, that's promising, but it's not a definitive proof. You may have just got lucky. Of course, if they gave different results, then you know you did something wrong. But if you got the same results, you might have just been lucky. So what we would say is do the logical gymnastics and apply the laws of logic. Now, I've shown you a few laws of logic, but there are others that are described in Appendix B. And finally, if you're a masochist, you can work your way through the truth tables if you want. So, in one sense, there are people who love doing this logic, and this could be a fun video based on a fun chapter. However, it can also be time-consuming. So let me summarize by saying, from a practical point of view, understand the content of Section A, which is pretty easy. Understand the content of Section B, which takes a little work, but it's not all that difficult, and you can skip Section C. So this is the last page, and what we have is the option of